In this video, I will re-explain this example using a Statcrunch. First of all, we already know during the class that we believe that the demand for the cakes or pies is uniformly distributed over Monday to Friday. So that's why here we write the null hypothesis is uniform over Monday to Friday. Alternative is always opposite to null hypothesis. I want to make a hypothesis test using alpha 0.05 using a Statcrunch. So here we are giving the data. Because we are giving this data, so we call this data as observed data. So here from Monday up to Friday, these data we call them observed. So I write them here as observed. We expect that we sell the same amount of cakes over Monday to Friday. So because we believe that we sell the same number of cakes and we believe that it's uniformly distributed, that means the same number of cake over Monday to Friday. So to find the uniform distribution in Statcrunch, we have two different ways. The first way is we sum the values, 358 plus 402 and up to 380, divided by the number, how many of them? So we have 5. So when we sum them, we have 2,120 divided by 5 days. So we get 424. So this is what we expected. So I write them here, 424. Why they are equal? Because we assume that we sell the same number of cakes from Monday to Friday, equally likely, uniformly distributed. So the first way to calculate this one in Statcrunch, I go to Stat, goodness of fit, chi-square test. They ask me where is the observed. I save them in this variable, observe. So I will select it. Then they ask me where is the expected. This is the expected. And then I just press compute. Here we go. This is the chi-square test. We called it statistics test. And this is the degree of freedom. How we find the degree of freedom manually. The degree of freedom is how many category we have. So here we have 5 days. 5 minus 1 equal 4. Here is the b-value. And this is the observed and expected. So we can compare alpha, b-value with alpha. So we can say that, okay, b-value here is less than alpha, so we reject the null hypothesis. Or we can compare the chi-square test with the chi-square alpha. How we find the critical value? How we can find chi-square alpha? Stat, calculator, chi-square. Here I must always keep upper tail test. Here we write the degree of freedom. To find the critical value, chi-square alpha, we write alpha here, and when we press compute, this is the chi-square. This is the chi-square alpha here. Okay, and here degree of freedom k, how many days I have, minus 1, which is 5 minus 1 equal 4. And here the chi-square test, which is 72. Now we can see 72 is extremely larger than 9. So because it's larger than the critical value, we reject the null hypothesis. Also, as I said, we can compare with p-value. This is the first way. The second way, how, before I tell you the second way, how I find the p-value from calculator. To find the p-value, you write the degree freedom And here you have to write the chi-square test. When you write the chi-square test here and press compute, you will have the p-value. Okay? But if you write alpha here, you get the chi-square alpha here. What is the another way, which is so much easy, but only works with uniform? Another way to do so, I just go to stat, goodness of fit, chi-square test. When they ask me about observed, I will select observed, but when I come to expected, I go to all cell in equal proportion. So I don't need to sum them divided by their number. I just can do them like this way. However, you must learn the two ways using the uniform, using Statcrunch. Compute, here we go. The same, the first way. This is another option, and you can complete the question the same way I answered the first way. The third way, we can do it manually. This is the data. This is the observed given in the question. So you must find the expected yourself, as I told you how you find them. After that, you have to minus each observation from the corresponding expected, which is in this case, give me minus 66. And then I square minus 66, which I have 4,356. After that, I divide 4,356 by the expected, which is give me 10.27. I do the same for the rest of the data, and then when I sum the last column, I will get the chi-square test, which is here. We can see it is deeply inside the rejection region, so I reject the null hypothesis. The data is not uniformly distributed. Thank you.